Okay, I noticed this one in the package here. This package that I sent out is called Stats Review Questions, Cumulative Frequency and Bivariate Statistics. So this is just in case you want to see which file this is from. This is this one here, if you look, and it starts off with a box and whisker. So quiz review, practice 14D stats. So in here, there's question 9, and I thought this was a little bit more difficult, so I thought I would give you guys an example or sort of a solution for this so you can see how we did this. The first bit was quite easy as long as you know a little bit about correlation. As you can see, you have a negative correlation here, and they give you the R value of 0.998, which is very, very strong. So it says state 2 words that describe the linear correlation between ln m and t. So like I said, very strong correlation and negative correlation. So if you have those 2 words in there, then they should be all right, if that's what they're looking for. Okay, you need both of them. Now the second piece here is the equation of line of best fit is ln m is equal to negative 0.12 t plus 4.67. And now they say, given that m is equal to this, find the value of b. So what they've done is they've taken this log equation and they've isolated for m. And a long time ago, we found out that if you have a is equal to b to the power of x, we can write this in the log, and this is in your formula booklet. So if you open up your formula booklet, and I'll bring it up so that we have it. And we go to the log section. Remember, if you have to work with logs, you should open up your formula booklet. And if we scroll down here to the logarithmic section, we have this simple SL 1.5, a to the x is equal to b. So actually I've written it wrong here. I'll change it so that it's exactly what they have in the book. And I'll cut it out even here so that we can see. So if I cut this out, and this allows you to transfer logs to exponentials and exponentials to logs. So this is very important. So essentially what you have in this question is you have this ln m, which is this side here, and then you have this other side, which is your x. Okay, so in this case they have 2 values added together, and how they change it is they say the small a in here is the base. So in ln, the base is e. Everyone should know that ln, the base, that is e. So if take e, so I'm going to rewrite this as e, so that's my a, e to the power of x, and x here is negative 0.212 t plus 4.67. So that's everything onto this side. So everything that considers x is just anything on the other side of the log. So that's all this here that contains there. So base to the power of the other side, which is x, is equal to the argument b, and in this case our argument for the ln is m. So there we've isolated for m, and you can see we have a t here which kind of looks like that, but we have this added. So this is where you have to have a little bit of algebra and indices skills. So if I have x squared times x cubed, you can bring them together like so. But if you have 2 numbers added together as exponents with a base of x, you can separate it back again like this here. So what I'm going to do is e, it doesn't matter, it's an x, it's at my base, and I'm going to separate it so I have e 0.12 t times e 4.67, and that's equal to my m. So as you can see, if you multiply these 2 e's with the same base, you add the arguments, which is this. So we've pulled them apart. And now if we look what our answer is looking for, it says a times b to the power of t. So I'm going to switch this around. So I have e to the 4.67 times e to the minus 0.12t, and that's equal to my m. So now I'm going to rewrite this thing here that's in the question. M is equal to a times b to the power of t. All right? And in this question, they ask you to find the value of b, don't they? So if you look at that, you have this, this b here. And what you can see is they're very close together. So something to the power of t, and this for sure is the last tricky step, is that if you have e to the negative 0.12, if that's to the power of t, that's the same thing as this bit here. And what they're asking you for is b to the power of t. So in this case, your final answer, b, has to equal to e to the minus 0.12. So a lot of really tough log equations and manipulating logs and indice laws, really sneaky indice laws. So take a look at that and let me know if you have any questions on how this question was handled.